Let's start working on question 1 now. So we have to compute the following definite integrals. So let's do part A. We have it over here. Now what's the intuition behind definite integral? So this function, this is the function that we're integrating. This function over here is a graph. If we draw it on the xy axis, we're going to have a graph. And just for the sake of the intuition, let's pretend that we have this function like that. So the xy axis, let's draw some negative values as well. Now, let's suppose that the function that we're trying to integrate has the following shape. So let's say it's something like that. This is our f of x. Because we're integrating on an interval between -1 and 3, these values belong to the x-axis. So between the value of x equals to -1 and x equals to 3, the area below the curve, that's what we're calculating. The value that we're going to find is going to be this area over here. So this is going to be our area. Now, how do we do that? Well, step by step. First of all, we have to integrate every term. We're going to integrate, and then we're going to substitute values into the results. So let's see how we're doing that. What's the integral of 3 times x to the power of 2? Well, we're going to have 3 times, because 3 is the constant, so we keep it like that. The integral of x squared dx, that's going to be x to the power of 2 plus 1, which is 3, divided by 2 plus 1, which is also 3. Now we go to the second term and we do the same method. So minus the integral of 4x dx. Well, we keep the constant, so minus 4. What is the integral of x dx? Well, that's x to the power of 1 plus 1, which is 2, divided by 1 plus 1, which is also 2. And we do one more, the last term, plus the integral of 1 dx. What is that? Well, the integral of dx basically is just x, because the derivative of x is going to be 1. Remember, the integral is the antiderivative. We find the value which, if we differentiate, we get back to 1. Hope this makes sense. So plus x. These are the results. These are the results. And now we have to substitute the values. So we close the brackets over here. Let me just change colors real quick. We close the brackets over here. And now we're going to substitute the following values. 3 and -1. So -1 and 3. Now we start with the upper bound, so we're going to substitute 3 into the axis. So let's see what we get. We will have the following results. So let's do it over here below. We will have 3, actually before that, let's cancel out some stuff to make it more simple. 3 and 3 cancel out, and then 4 with 2 also cancel out. So we have here only 2 times x squared. Now we can do our math. So we will have the following. We will have 3 to the power of 3, so we have 3 to the power of 3 minus 2 times 3 squared, so 2 times 3 squared, plus 3 instead of x, so plus 3. Now this is one bracket. We have to subtract, so minus the second bracket. And in the second bracket, we're going to substitute the value of -1 into the axis. So we're going to have -1 to the power of 3, so it's -1 to the power of 3, minus 2 times -1 to the power of 2, so 2 times -1 to the power of 2, and then plus -1, so plus -1. Close the brackets over here. Now let's see what we get. What's 3 to the power of 3? Well, that's 27. So over here we have 27 minus 2 times 3 to the power of 2, that's 2 times 9, which is 18, plus 3, and then we subtract the remaining bracket. So minus, and what do we have in the remaining bracket? That's -1 to the power of 3, which is -1, minus 2 times -1 squared, that's 2 times 1, and then plus -1 is just -1, and we close this bracket. Now, let's do the math again. What's 27 minus 18? That's equal to 9, plus 3, that's going to be 12, minus, what do we have here? -1, -2, that's -3, -3 minus 1, that's -4, so we have -4. What do we have as a final answer? Well, that's going to be 12 plus 4, which is equal to 16, and that is the area underneath the curve. Hope this makes sense. Next video we go to part B.